Good afternoon to everyone. Myself Harsh Pratap Singh from Kirorimal College, University of Delhi. So I am here to present on the topic equivalence principle and its consequences. So equivalence principle is the very important principle given by Mr. Albert Einstein in 1907. So he had given this principle to formulate the general theory of relativity. So basically, Einstein has already formulated a special theory of relativity, but the defect was that it was only applicable for constant speed and it was not applicable for acceleration. So he have to introduce a general theory of relativity which is generalized for the accelerated frame of references as well as non-accelerated frame of references. So basically, let us have a little idea about equivalence principle. So it basically describes that suppose we are having two observer, one observer in an accelerator which is there in outer space without any gravitational effects on it, and another observer is in a elevator which is freely falling on the in the surrounding of the earth under the gravitational effect. So both these observer cannot tell the difference between the two situation without seeing outside this elevator because both of the effects are same. So we can say that a falling man cannot experience gravitational effect on it. So now, why there is a need for introducing a new theory of gravity? So Newton formulation of gravity doesn't mention about time. So you know that Newton has given the formula F is equal to g m1 m2 upon r square, where this is the force between two masses m1 and m2 separated by distance r. So that formula doesn't talks about time. That means how this effect is traveling from one mass to other mass. So at that time it was assumed that this effect is traveling with infinite speed, but after special theory of relativity it came into existence that it will be violated if this effect or if this physical effect is traveling faster than speed of light. So according to Newton equation, the effect of gravitational force is instantaneous. So it leads to the contradiction of special theory of relativity. And so there is a need to reformulate gravity, and that's why equivalence principle came into existence. So now came the happiest thought of Einstein life. So what Einstein was imagined that a man falling from a roof of the house, at least in his immediate surrounding, cannot experience a gravitational pull. So basically the statement of equivalence principle says that the inertial mass and the gravitational masses are equal. So first of all, let us talk about what is difference between inertial mass and gravitational mass. So inertial mass is the mass which have to tell the object that how to behave in an accelerated frame of reference, and a gravitational mass is the mass of an object when it is put under the gravitational effect. So these two masses are completely given by different theories, one given by inertial and other given by gravitational theory. So these two masses are equivalent, that was given by the equivalence principle. So the principle describes the equivalence of acceleration and gravity. So the general theory of relativity came into existence, and it is the consequence of equivalence principle. So now special theory of relativity versus general theory of relativity. That means we are just comparing the STR with GTR. So the special theory of relativity talks about inertial frame, and it says that all inertial frame are equivalent. Or we can also say it is one of the postulate of special theory of relativity that the physical laws are same in all inertial frame of references. And in general theory of relativity, it says that inertial and gravitational masses are equivalent. So both talks about the equivalent of something, but they are completely different. One talk about the equivalence of constant frames moving with constant velocity, but another describes about the equivalence of gravitational and inertial mass. So the gravitational field has only a relative existence because for an observer freely falling from the roof of the house, at least in his immediate surrounding, does not feel any gravitational existence or any existence of gravitational field. So basically what this particular statement means is that observer falling from the roof of the house, at least in his local surrounding. That means equivalence principle is only applicable for local surroundings. So now there is a statement which equivalence principle has given. It gives the equivalence of acceleration and gravity. So is gravity a illusion only, that it's the effect of acceleration only? So of course it's not, because gravity is somewhat different from, little different from acceleration, but we can differentiate between these two things when we are considering large frame of references. For local frame of references, these two effects looks to be same. So now the question arises, then how to differentiate between acceleration and gravity. So differentiating between acceleration and gravity, so here we are taking two objects, like we have taken two apples here. They are separated by some particular distance, and when they are falling under the influence of lunar gravity, so these are moving in a path conical, in this path of conical. So the separation between these two objects is decreasing with time. But if we imagine a big accelerator and these two objects are put at their ends, and that is accelerated with some acceleration which is equivalent to the lunar gravity, then they will fall in this pattern, like cylindrical surface pattern. So that will that means that their separation is not a function of time. So we can differentiate in this way in acceleration and gravity. So now effect of gravity on light, excellent consequence of equivalence principle. So how acceleration leads to bending of light. So we can understand this beautiful fact using equivalence principle. So to an observer in inertial frame of reference, light is having a rectilinear propagation. But for an observer in the accelerating frame of reference, the light is bending. So how can we take this effect into account? So we can consider this effect by considering an elevator, and a person shines a laser into that elevator or some light beam, and a person standing outside will going to see that the light beam is going straight, like this. You can see here the light beam is going to be straight, but it is the bottom of the elevator which is moving upward. So a person inside the elevator will going to see the bending of light, but it is not actually happening there, because of course someone think that the observer outside is right, because inside is just having an illusion only. But it's not correct according to general theory of relativity. It says that both are right in their frame of references. So the story changes with the frame of references. So this is the effect of acceleration on the bending of light. So we can easily transform that effect to gravity by using equivalence principle, as we say that acceleration and gravity are the same thing for the local frame of references. So we can say that light bends in a gravitational field. So that is the transformation effect of the gravity, and this phenomena is called as gravitational lensing.